All right, this is going on page 138 when we're done. Yesterday, we looked at parametric equations and we graphed some. Today, we're going to take two parametric equations and put them back into rectangular form, meaning that you could just graph them like you are normally used to graphing. Then tomorrow, we're going to take a rectangular equation and break it apart into two parametric equations and kind of look at some applications, like why would you want to do that and why would we be doing that? So let's look at what this says. It says to write parametric equations in rectangular form, you must eliminate the parameter t. So we use the following process. Solve one parametric equation for t. Substitute the resulting expression into the other parametric equation and simplify. It's basically like substitution. If you just pretend like it's a system of equations, that's basically the same type of thing you've been doing. Okay. So then it says write each pair of parametric equations in rectangular form and then note any restrictions in the domain. That's very important. Now that's going to be pretty obvious when it needs to be done. Either they will have given us an interval kind of down like on 5 and 6, and so we have to take that into account, or we will end up with something like under the square root or something that we know we have to worry about the domain on. So it's not anything you have to check each time or anything like that. We start off with all real numbers on number 1. I mean, that's what the domain is going to be for those because they're linear, and then nothing weird's going to happen. So it's like I said, you'll see when we go through this, it should be kind of obvious when you have to worry about it. So when you look at here, it doesn't matter whether you use the x equation or the y equation to solve for t, use the easiest one. And that's usually a matter of opinion, but we usually can agree. Would you agree that y is probably a little simpler? Yes? So in order to solve for t, I'm going to move t over to the left to make it a positive t, and that's going to be equal to 6 minus y. Okay. Then I'm going to take that, now that I have my t equation, and I'm going to take that 6 minus y, substitute it in for t right here. So I'm going to get x equals 4 times 6 minus y minus 1. And then I'm going to need to get y by itself. I could multiply through right here if I wanted to, or I don't necessarily have to. If I don't multiply through, then right here I could just add 1 to both sides, and I get x plus 1 equals 4 times 6 minus y. Then what could I do? Divide by 4. And dividing by 4 is the same as multiplying by 1/4. You agree with that? So I'm actually going to multiply by 1/4 and leave it like this. Okay? And that's going to equal 6 minus y. So then I'm going to subtract 6 from both sides. So I will get 1/4 times x minus 1. I'm sorry, x plus 1, minus 6 equals negative y. But I don't want negative y, I want positive y. So if I just multiply both sides by a negative 1, we get y equals negative 1/4 times x plus 1 plus 6. That's my answer. My answer would look different if I had actually multiplied the 4 through up there, which wouldn't have necessarily made it any more difficult. And even if I had to multiply the 1/4 through. But you're going to want to leave it in this form. Most of the time it'll make your life easier. Plus, you work real hard sometimes to get them in that form so that it tells you certain things. And so if you're already there, don't get it out of that form. We good? All right, so let's look at number 2. What do we want to solve for on number 2? Y. Okay, so I'm going to solve for y. That's going to give me t equals y over 3. So then I substitute that in. I'm going to get x equals y over 3 squared plus 5. Okay. So y over 3 squared is what? Y squared over 9, and then plus 5. So I'm going to subtract 5 from both sides. So do x minus 5 equals y squared over 9. I want to get y by itself, so I'm going to multiply both sides by 9. So y squared is equal to 9 times x minus 5. And it's fine to leave it as y squared, so we're done. No, because we haven't done a square root. So we're good. Everybody good so far? No, if you don't what? Okay. All right. Yeah, we haven't had to worry about the domain just yet. So let's look at number 3. What do you want to solve for in number 3? Yeah, that's the x equation. I'm sorry, use the x equation. Yeah, so we'll do x minus 1 So x minus 1 equals negative 4t. So when I divide, again, instead of thinking about dividing by a negative 4, I'm multiplying by a negative 1/4. So t is going to equal negative 1/4 times x minus 1. That's going to make things a little easier in the end than having to multiply everything out every time. So now I have this x equation solved for t, so I'm going to substitute it into the y equation. So y is equal to 2 times, so t is negative 1/4 times x minus 1 squared plus 5. Everybody good with that so far? So when I square this part here, yes, there's two terms in here, but as far as what's in the brackets, I just have this times this, so I can square this one and square that one. So I get y equals 2 times, what's negative 1/4 squared? 1/16. And then this would be x minus 1 quantity squared, and then plus 5. So I still have to multiply by 2. That will give me y equals 1/8 times x minus 1 squared plus 5. And I'm done. Okay, everybody okay with that? Any questions at all? All right, you work on number 4. Get it started, because I'm going to go get my paper so I can make sure that I'm right on these. Sorry. What am I doing? Oh, why? That's why I was like, what the heck? Okay, shoots. Sorry, it is y plus 7, and this should be y plus 7. Thank you. Squared minus 3. Okay, so do we all at least get here? Did I get there correctly finally? So that means this is going to give me x equals 1/4 times y plus 7 squared minus 3. Now I need to get y by itself. I do not need to multiply everything out. I can start by adding 3 to both sides, so I get x plus 3 equals 1/4 times y plus 7 squared. Then what can I do next? Multiply by 4. So I have 4 times x plus 3 equals y plus 7 squared. Then what would I do? Square root of both sides. So that means when I take the square root of this side, I get plus or minus the square root of 4 times x plus 3, and that equals y plus 7. So then I'm going to need to subtract 7 from both sides. When I do that, first of all, this here, this is two things being multiplied together. I can actually take the square root of 4. So this is plus or minus 2 times the square root of x plus 3 minus 7. You can put the 7 at the end, or you can put it at the beginning. If you put it at the end, make sure that your square root doesn't go crazy and look like it's engulfing the 7 as well. Okay? You can't have crazy square roots out there. I also want to make sure that you understand that if I had this, that I would not be able to take the square root of 4 there. Right? You understand the difference? If I did this, that's okay. Then I can, because there's two things multiplied together. Right? Make sure you understand the difference so you don't start making up math at some point. Okay, any questions at all? Yes, ma'am. I'm not sure. We didn't solve for x and y. I used the x. Well, x was already by itself. It's because on this one, I used the x equation to get my t, and here I use my y equation, just because it was the easier one. So then I substituted this one into the x equation. I substituted this one into the y equation. So you're solving for y every time unless they're both squared. Because, yeah, anytime it's an x and y thing, you know, think functionally, you want to solve for y unless they're both squared, then that's just a whole different issue. Okay, good question. Anything else? All right. So, okay. Oh, we would. Thank you. I got distracted. We have to do the domain on this one, right? Because I got under square root. Because what cannot happen under the square root? Yeah, I can't have a negative. It can't be negative underneath there. And so my x value then here is going to have to be greater than or equal to what? -3, right? -3. So yes, thank you. Move on too fast, right? Because 0 is okay, but a negative under the square root would not be okay. All right, and then on 5 and 6, we definitely have to worry about the domain because they give us these restrictions for t. So we will come back to that. Like, we can't forget that this is important, but we're going to do that at the end. So we'll do everything else the same, and then you just focus on that in the end. So I would say we want to solve the x equation, right? So this is going to give me x plus 3 equals 1/2 t. So t is equal to 2 times x plus 3. So then I substitute that into the y equation. It's going to give me y equals 2 times x plus 3 squared minus 7. So y is equal to 4 times x plus 3 squared minus 7. So here's my equation. It doesn't look like I should have any domain restrictions, right? But the reason I do is because t was restricted. So since t was restricted, there is no t in here, right? We've eliminated that variable. But the domain now is based on x. So you take this and try and figure it out from here. So since t has to be between 2 and 8, I'm going to take the 2 for t, substitute it in here, and see what x value that would give me. So x is equal to 1/2 times 2 minus 3. So that's going to give me x equals -2. And I know that that's easy to do in your head, and you probably don't need to write it down when you actually do it in your notes. Write it down. Because otherwise you're going to go back and look at the domain and think magic happened and have no clue where those numbers came from. Right? So I would not necessarily expect you to write all this out every time, but I do think in your notes the first time it's important. So that means our x minimum would be -2, and then we got to figure out what the other side is. So I plug in the 8. X is equal to 1/2 times 8 minus 3. So that means x equals 1. So my restriction on my domain, then x has to go from -2 to 1 because t is going from 2 to 8. Okay, does that make sense? You're always going to plug it into the x because x is the domain. Questions? All right, so we are going to do number 6 together because I want to show you where you don't have to go as far as some of you probably will think you have to. They both have squared in them, so one's not necessarily any easier than the other, but we'll use the x equation. So I'm going to do x plus 4 equals t squared. Well, I do not always have to solve for t. I think the directions says, I mean, it's kind of the steps, but that's not what that really means literally. This is t squared. Well, guess what? I need a t squared in there. There's no use in finding t and putting it back in and squaring it. If t squared is x plus 4, then I can substitute that in right there. Y equals x plus 4 plus 1. So y equals x plus 5. And it's that easy. Okay? So no reason to make it harder, right? So you find the domain restriction on this. Oops. So what are my numbers? -3 and 12. Good. All right. Does anyone have any questions? Or what questions do you have? All right. Let's look on the back. All right. On number 7, you're going to take the y equation, solve that one for t, substitute it in, and work it out on your own. Go for it. And let me just tell you, if you're struggling with this one, it has absolutely nothing to do with parametric equations, absolutely nothing to do with pre-cal at all. It's 4th grade math that you're struggling with. It's fractions, that's what it is. You don't know what to do with fractions. It has absolutely nothing to do with the content right now. It's the skills you have to work through all this stuff. Okay, so I'm going to get a common denominator in my numerator, which will give me 1 plus 2y over y, or 1 over y. Then I'm going to take 1 plus 2y over y, multiply it by y over 1. So x is equal to 1 plus 2y. X minus 1 equals 2y. And y equals 1/2 times x minus 1. Any questions at all? Okay, fractions. Fractions. If you still don't know fractions, you really are wasting your time going to calculus. I'm going to be real honest with you. If you're just never going to go get them figured out, it's a complete, big, huge waste of your time. All right, so most of this class has been a waste of your time too, because you probably hadn't understood most of it. But you've got to be able to do back. This is basic fraction stuff. It's not even crazy partial fraction or anything like that. All right, let's look at number 8. On number 8, I would say that y probably looks easier to use there, but then you're going to have to put it in the square root. I think it might be better just to kind of go ahead and get rid of the square root. So we're actually going to use x and solve for that one, or use that one to solve for t. So I'm going to take x minus 5. It's going to equal the square root of t minus 3. So then I can square both sides and get x minus 5 squared equals t minus 3. So t equals x minus 5 squared plus 3. Okay, so there's my t equation. Now, I have a domain restriction, right? They didn't give me anything about t, but I know from up here that there is something. So we'll come back to that, but we do have to look at it. So then I'm going to take this, substitute it in here. So y is equal to 1/2 times x minus 5 squared plus 3 plus 8. That means y equals 1/2 times x minus 5 squared plus 3/2 plus 8. Y is equal to 1/2 times x minus 5 squared plus what? 19 over 2. All right, so then I got to go back and look at my restrictions on my domain. I know from the very beginning up here that t has to be greater than or equal to what? 3, right? That means that this right here is t. So x minus 5 squared plus 3 has to be greater than or equal to 3. So subtract 3 from both sides. X minus 5 squared has to be greater than or equal to 0. Well, there's my quadratic factored already. That's one reason why we don't want to multiply it all out. So I just have to do x minus 5 is greater than or equal to 0, which means that x has to be greater than or equal to 5. Any questions at all? Or what are your questions? Uh-huh. Yeah, this is really the same thing, and that would work here too. But this wasn't a compound inequality, so I didn't do it that way, but you can still do it that way. If you take 3 and substitute it in here, you're going to get 0 plus 5, so you get 5, and then it's the same thing. X is greater than or equal to 5. It'll work that way too. Because you should know that for a square root, you can't have a negative. So if you have anything like that you know you've had to look at domains before, then you have to do that. Does that make sense to you? If they're just squared or something like that, that's fine. But if there's a square root in there somewhere, then we got to worry about our domain, so we don't get negatives. Does that make sense? Yes. That's fine because it's -2 plus 3, so it will be still positive underneath. Does that make sense? So x can be negative. Whatever you end up with under the square root can't be negative. Does that make sense? That's a good question. All right. What else? Okay. All right, so let's look at the polar part of this, which is actually a whole lot easier, believe it or not. It says the graph of a polar equation, r equals f of theta, is the same as the graph of these parametric equations. All right, so there's a couple things we know. We know that x equals r cosine theta, and we know that y equals r cosine theta. No, it doesn't. It equals sine. Oh my goodness, bless you. They can't equal the same thing. It is r sine theta. I'll get this correct. That stuff we already knew, right? But then since r equals f of theta, I can substitute that in right here. So x equals f of theta times cosine theta, and y equals f of theta times sine theta, where theta is your parameter here instead of t. This is where the whole unit circle thing comes from, because you have, well, let's do number 9, and then we'll look at that. So this just says r equals 3. It says write each polar equation as a pair of parametric equations. So we're going to take this one equation and split it up. Well, if x is equal to r cosine theta and r equals 3, then x equals 3 cosine theta. That's that one. And then I put 3 in over here, and y is equal to 3 sine theta, and that's it. So you know how in the unit circle we have x and y values that we talked about with square roots that we all came from the special right triangles? So we'd have this ordered pair on the circle, right? That might be, we'd have like square root of 2 over 2, square root of 2 over 2, right? That's your x and your y. But that's also the cosine of theta and the sine of theta. So your x value is the cosine of theta, your y value is the sine of theta. This just has a 3 in it because the radius isn't 1, it's 3. But that's how that graph, that's how you get that circle, and you have those ordered pairs where you have cosine and sine. Say that one more time. So yeah, yes, exactly. So if the radius of this circle was 3 and that we're using our unit circle values, then with the radius of 3 and that 45 degrees or that pi force, then it would, yes, be 3 square root of 2 over 2, 3 square root of 2 over 2. Exactly. That's all that is. All right. So then we look at 10. We're going to do it the exact same way. We have r. We substitute it in. So if I take r and I substitute it right there, I'm going to get x equals 4 sine theta cosine theta. And I can't do anything else with that, so I'm done. Then to substitute it in over here, I'm going to get y equals 4 sine theta sine theta. So that means that y equals 4 what? Sine squared theta. Any questions at all? Because that over there, these both graph circles, but this doesn't graph a circle that's centered at the origin. This one does, and that's why it works with that whole unit circle idea. Okay. We good already so far? All right. Let's look at the bottom here. So these are a little bit different. We're not using those equations that are up there. It says write each. Now I have 2 parametric equations, and we're going to write them in rectangular by eliminating the parameter theta. So we're going to get rid of theta here, which means I need to have something that I can substitute in for sine and cosine. And this right here says use trigonometric identities to eliminate the parameter. So in order for me to do that, I have to get cosine and sine by themselves. So I'm going to divide both sides by 3. X over 3 equals cosine theta. And here y over 2 equals sine theta. Then I have to figure out something that I can do with this. Well, here's something that I know about this. I know that cosine squared theta plus sine squared theta equals 1. So I have something I can substitute in for cosine. I have something I can substitute in for sine. So here I'm going to get x over 3 squared plus y over 2 squared equals 1. That means I get x squared over 9 plus y squared over 4 equals 1. And I'm done. Anybody know what that graphs? It graphs an ellipse. So when you did circles in Algebra 2, you talked about ellipses like that much. Like maybe not even did a full lesson on it, just maybe just shown or exposed to it. And because you don't really do them in Algebra 2 anymore, and you don't do them in Pre-Cal anymore. So there's your one little exposure to what an ellipse equation looks like. All right, you do number 12. What? It depends on the, yeah. You will on number 12. Do number 12. And your x term needs to come first. Even if here it doesn't, but in the end you need to write it first. Why? Because that's the form of the equation and that's the way it's supposed to be. Just because it is. Okay, we all good? All right, so number 13 is just a little bit different. We have x equals sine squared. So sine's already by itself, and the fact that it's sine squared and not sine is fine. Cosine is not by itself, so I need to get it that way. So I'm going to have y over 4 equals cosine theta. Well, I'm still just dealing with sine and cosine. So I can still use that Pythagorean identity of sine squared theta plus cosine squared theta equals 1. The difference is I have sine squared, so when I substitute that in, I'm just substituting in x. It's not getting squared. Plus, and then all I have is cosine, so I do have to square that. That's y over 4 squared equals 1. Then since they're not both squared, I am going to have to solve for y. So this is going to give me x squared plus y squared over 6, oh not x squared, oh my goodness, equals 1. X is not squared, you don't get to magically square it. Sorry, got carried away there. I know, it's just x. I just really wanted it to be squared. So then I'm going to subtract x over, so I'll get y squared over 16 equals 1 minus x. Then multiply both sides by 16, so y squared is equal to 16 times 1 minus x. And on the trig ones, you're not going to have to worry about the domain. Don't worry about those, just they're all going to come out just fine anyway. All right, now let's look at 14. 14, we've got a cosine 2 theta. So cosine 2 theta was one of the ones where you had multiple options on what to choose. So get your reference sheets out and let's see if we can make an educated decision on which one to use. If you use there's not a wrong one. It's just going to take more steps to get to where you need to be. Okay, go ahead. Because if they're not both squared, you always solve for y. Or y squared, either. So these two up here, they both had x squared and y squared. Right? And so then you have this one, since it's just y squared, we're solving for y. Even if it was x squared and not y, then we'd still solve for y, because it's just what we do with functions. And this actually wouldn't be a function, but we could make it into one. We just solve for y. All right, so you have 3 options, 1, 2, and 3. So what do you think the best option might be? Okay, so I got a 1 minus 2 sine squared and a 2 cosine squared votes there. So why are you picking the sine one? Okay, do I have a sine in here? No? Okay, so even though I didn't have a sine in there, I had somebody that was adamant second period about doing 1 minus 2 sine squared. And even asked me, is it wrong? Well, it's not wrong. So I had him kind of explain to me why, what he was going to do with that. That was the one he thought he should use, so that's fine. But then he had to use this to be able to get the sine squared out. And basically when you do that, you end up with number 3 anyway. So he wasn't doing anything wrong. He was just longer steps, but sometimes that's what happens. But since I don't even have a sign to put in there, then going with that cosine one, which is the third one, is good. So what I know then from my reference chart is that cosine 2 theta is equal to 2 cosine squared theta minus 1. So now I have something that I can substitute all of the pieces that I have in there. Cosine 2 theta is actually x. That's equal to 2. Well, cosine theta is y, so it's going to be y squared minus 1. Y equals cosine, so cosine squared is going to have to be y squared. Just substituted that piece in. Yes? Okay, so then I add 1 to both sides. X plus 1 equals 2y squared. So y squared equals 1/2 times x plus 1. What questions do you have? It's not that bad. It's a whole lot of algebra. I mean, honestly, the pre-cal part of it is knowing that you have to plug the t in, but then after that, it's all just algebra. Even this stuff, the trig stuff, I mean, it's technically just the algebra that goes along with it. You just have to know the trig pieces. Yes, so you already have the assignment. The graphs were from yesterday, and then the rest of it is this. Okay, so you already have it. Get to work on it. Let me know what questions you have so that you can get it done. And what room do you meet me in tomorrow? 428. Okay, at least get on the right hall and I think you'll be fine.